Hello and welcome to day two of my 100 days of Kubernetes. Today we're looking at the Kubernetes architecture and what a Kubernetes cluster has or entails and how they interact. So we'll be taking a look at the Kubernetes architecture, typical Kubernetes cluster, the two major components, which are the control plane and the worker nodes. Um, for a simple cluster, we could have one control plane with several worker nodes. For production cases, however, we can have more than two control planes with lots and lots of worker nodes. So for a control plane, we have the API server, the scheduler, as well as the controller manager and the etcd. For the kubelet, however, we have the container runtime, the kubeproxy, as well as the kubelet. Okay, so let's look at all this one after the other. The control plane is the powerhouse of the Kubernetes cluster, and it contains the most important component of the entire cluster. The control plane is the most important because it runs the etcd, which is a key value data store that stores the state of the Kubernetes cluster at any given time. This component here are what makes the decisions for the cluster, because what happens, how pods are scheduled, how nodes are created, are all determined by the control plane. So this component now, let's look at them one after the other. The etcd is a key value data store that is highly persistent and is responsible for backup and storage for all cluster data. Data such as the cluster state, the metadata, the configuration data, whatever data, everything is stored in the etcd. And backup needs to be done by a Kubernetes administrator, either manually or using another tool, because Kubernetes does not support this natively. Okay, so the next is the API server. The API server is the front end or the entry point into any Kubernetes cluster. So interaction with the Kubernetes API or with the worker nodes takes place using the API server. The controller manager, which keeps track of what is going on in the cluster and makes changes to ensure that the cluster is running in the desired state. Highly declarative, which means that after we've declared the state where we want our cluster to be or what we want our cluster to be like, then it goes ahead and provisions what is actually needed, the components that it needs to go ahead and do its job. So controller manager is what now checks at intervals what I'm running or what is running in this cluster at this particular moment. Is it the same as what was declared when said? So what I have now, is it the same as what I should be running? So it does this continuous communication with the API server to let it know that, okay, and if anytime it finds a disparity between the the desired state as well as the current state, it lets the API server know, and then the API server signals to the kubelet in the worker node and goes ahead and creates whatever resource that is lacking at that point. The scheduler is what ensures that pods are placed in nodes based on workload and resource requirements. So let's say, for example, I need to create, I need to deploy a new container or a new pod. Okay, so before I even go on, I should say a pod is the smallest unit in a Kubernetes cluster, because it is what the container image actually runs on. I felt that the the container engine or the container runtime should actually run directly on the node, but obviously that isn't how it is. We actually do a deeper dive on pods later on, but for now, let's look at the worker. A worker node is a physical or virtual machine that runs containerized applications. Worker nodes are controlled by the control plane, and this is where the application runs. So in size, it's actually quite heavier than the control plane, because the applications actually run on the worker nodes. the container runtime, the kubelet, as well as the proxy are the major components of worker nodes. So let's break this down as well. The kubelet is the primary agent that is responsible for starting up pods running on a node and communicates directly with the API server. So as the API server is the entry point into control plane, the kubelet is also the entry point to the worker. It communicates the state of running pods on any node and tells the API server about it. So the entry point, look at the container runtime. The runtime environment for executing containers, because Kubernetes does not interact directly with whatever or whichever container technology that we're using. So there is a level of abstraction running inside the container runtime, and it does not interact directly with the Kubernetes API or the Kubernetes cluster. Okay, so let's look at the proxy. The cluster is like a collection of different nodes that act as one unit. So in a Kubernetes cluster, that is what Kubernetes cluster literally means. Is this proxy that now allows communication between pods that are on a node as well as between nodes themselves. So altogether, they can all run as one powerful engine. Now that we're taking a look, let's now look at the connection on an architectural diagram. This is a typical Kubernetes cluster. My drawing has gotten better actually, and there has one control plane and 4 worker nodes. The worker nodes have the kubelet, container runtime, as well as the kube proxy. And the control plane has its own kube scheduler, the kube controller, the etcd, as well as the API server. So each of this all talk to each other. The control plane, in the control plane, all other components are actually connected to the API server, because the API server is what would interact with the outside world aside from the control plane. And okay, for the nodes, the kubelet is also talking to the API server. The kube proxy is also talking to the API server. So I guess we've done a good breakdown of what, we've had a breakdown of what a typical Kubernetes cluster looks like. And in my next video, I would be looking at pods majorly because they come up a lot, and I don't see it in the Kubernetes architecture. So I want to know how it fits into the whole bigger picture. So thank you for watching this video today, and I guess I'll see you soon.